Operating systems are the unsung heroes of our digital lives. They're the software that makes our computers work. They manage everything from the processor to the memory to the storage. Think of an operating system as the conductor of an orchestra. It ensures all the different parts of a computer work together in harmony. Without an operating system, our computers would be useless boxes of silicon and metal. They allow us to interact with our computers. They also provide a platform for running applications. From the moment you turn on your computer to the moment you shut it down, the operating system is hard at work. It ensures your computer runs smoothly and efficiently. A process is simply a program in execution. Every time you open a web browser, you create a process. When you edit a document, you create a process. Each process requires resources from the operating system to run. These resources include memory, processing power, and input-output devices. The operating system is responsible for managing these resources. It also ensures each process gets a fair share. This is crucial for keeping your computer running smoothly. If one process were to consume all the resources, it could bring the entire system to a grinding halt. To understand how processes work, we need to understand the process lifecycle. This cycle is often represented as a state diagram. A state diagram is a visual representation of the different states a process can be in. The diagram helps us visualize how a process transitions from one state to another. It's like a roadmap of a process's journey from creation to termination. Understanding these states is key to understanding how operating systems manage processes. The new state is the first state a process enters. This is when the operating system creates the process. It's like a seed being planted in the ground. The process is allocated the necessary resources. These resources include memory space and system resources. However, the process isn't running just yet. It's just been born and is waiting for its turn to run. Section 5. Ready state, waiting in the wings. The ready state is where a process waits for the CPU. The CPU is the brain of the computer. It executes the instructions of a process. Think of the ready state as a queue. Processes line up waiting for their turn to use the CPU. The operating system uses a scheduling algorithm to decide which process gets to use the CPU next. There are many different scheduling algorithms. Each has its own advantages and disadvantages. Section 6. Running state, taking center stage. The running state is where a process gets to shine. This is when the process has the CPU's attention. The CPU is executing the process instructions. It's like being called on stage to perform. The process can access all the resources it needs. It can perform its tasks until its time slice is up or it needs to wait for a resource. Section 7. Waiting state, awaiting resources. Sometimes a process needs something it doesn't have. This could be data from a hard drive or input from a user. When this happens, the process enters the waiting state. It's like being put on hold during a phone call. The process waits until the resource it needs becomes available. Once the resource is available, the process moves back to the ready state. It then waits for its turn to use the CPU again. Section 8. Terminated state, the end of the line. All good things must come to an end. The terminated state is the final state of a process. This is when the process has finished executing. It's like the final curtain call of a play. The operating system releases the resources the process was using. These resources are then available for other processes to use. The process is then removed from the system. Section 9. Real-world examples of process states. Let's say you're editing a document. When you open the word processor, you create a process. While you're typing, the process is in the running state. If you save the document, the process might enter the waiting state. It waits for the hard drive to save the data. Once the data is saved, the process goes back to the ready state. When you close the word processor, the process enters the terminated state. Understanding process states is essential for anyone who uses a computer. It gives you a glimpse into the inner workings of your operating system. It also helps you understand how your computer manages to run multiple programs at once. So the next time you open an application, take a moment to think about the journey of a process.